And now we're going to talk about standard form. And we like to write our equations in standard form. We've seen that it's easier to graph these things when they're in standard form. So this is a kind of a convention, and we have the rules that it should be in this form: ax plus by equals c. So our x's and y's are on the left, our numbers are on the right, and not both of these can be zero, and the leading coefficient should be positive. And they should not all be divisible by a particular number. So if we can reduce it, we can. So here's some examples. So here's the first one, right in standard form with your directions. So I see this, and again, my x's and y's are not on the same side. So I can fix that pretty fast just by using my properties of equations and transforming the equation. So what I'll do is I will just, first of all, subtract 4y from both sides to get all my y's on the left. So I'm going to move the y's on the right by subtracting 4y from both sides. And now I've got 2x minus 4y equals negative 8. Now you might think it's in standard form because I've got all my x's and y's on my left and my numbers on the right, but we can't have a common factor of all these, and all these numbers are divisible by 2, so I've got to divide that out, because it's really not in standard form if I can divide a number into all three terms. So I divide every term by 2, because 2 goes into all three terms. So we don't want to have a common factor. So 2 over 2 is 1, so now I just have x minus 4 over 2 is 2y, and that equals negative, and 8 over 2 is 4. So now that's in standard form. And once it's in standard form, you should be able to determine what your a, b, and c are. So a, b, c. So a would be whatever's in front of the x. And since we don't see anything, it's understood to be 1. B would be negative 2, and c would be negative 4. So that would be your standard form. Okay? So we want to have all the x's and y's on the left, the numbers on the right. Whatever is in front of the x should be positive, and we shouldn't have a common factor. And in this case, they all cannot be divisible by the same number. You have to divide that out if they are. Okay? Here's another example. Okay, so 1/5 x plus 3. So first of all, I got fractions. We don't like fractions. So the way we remove the fractions is we multiply every term in the equation. And remember, terms are separated by addition or minus signs. So I've got a term here, one term there, one term there. So I've got 3 terms. I multiply every term by the least common denominator, the LCD, which is the smallest denominator that all the denominators divide into. In this case, there's only 1, so it's going to be 5, so that's going to be 5. So I multiply every term by 5. I guess I can do that over here. 5 times y, 5 times 1/5, and 5 times 3. So on the left, I've got 5y. Now 5 over 5 is 1, so that's just 1x. And 3 times 5 is 15, so I got rid of my fractions. Now I want all my x's and y's on the left. So what I'll do is I'll subtract x from both sides. And now I've got, and I put the x in front, so I've got negative x plus 5y equals 15. But I can't have this negative, so I have to change all the signs. Now we could just change all the signs, or we could just divide everything by negative 1. Every term, negative 1, negative 1, negative 1, or just change all the signs. And we have positive x, negative 5y, and negative 15. So there you go. Sorry about that. Okay? So again, all right, just to recash, we have a fraction, so my least common denominator was 5, so I multiply every term by 5. 5y. 5 over 5 is 1, so just 1x. 3 times 5 is 15. Then I get all my x's on the left with the y, so I subtract x from both sides. So x minus x is 0, so I just have 15 on the right. And then if I subtract x over here, I've got negative x plus 5y, but I've got a negative leading sign, so I've got to change that. So if I divide everything by negative 1, that's going to make that positive. A negative over a negative is a positive. A positive over a negative is a negative. Positive over a negative is a negative. And there we have it in standard form. So what would my A be? If I have A, B, and C. So my A would be 1. My B would be negative 5. And my C would be negative 15. And now that's in standard form. Okay? That shouldn't be too bad. And I think I have one more we can do. I'll find some paper here. Here we go. So let's try one more. And this is we'll call this number 3. And this might be 1/2 y equals 1/3 x. And let's make it 2/3 x. And then minus 3 over 4. There we go. Okay, that's a nice one. All right, so we got all kinds of fractions and all kinds of goodies over here. So again, first thing we want to do is remove the fractions. So we have to determine what the LCD is. So I usually try to figure that out. So the LCD, the least common denominator. And we do this the same thing when we were adding fractions. We always try the largest one, and if that works, we're in business. And does 3 go into 4? No. Then I try twice the largest one. Does 3 go into 8? No. Then I try 3 times the largest one. And I keep doing that till I find one, a multiple of the largest denominator that the other two divide into evenly. So if I try 3 times 4, I get 12. Does 3 go into 12? Yes. Does 2 go into 12? Yes. So that's my least common denominator. So I write it down so I don't forget. It's 12. And then I'm going to multiply every term by 12. Let me rewrite this so you can actually see a little bit better what we're going to do. So I'm going to multiply every term, and remember terms are separated by positive and negative signs, so I've got 1, 2, 3 terms. So I'm going to multiply every term by the LCD. So 12 times 1/2, 12 times 2/3, and 12 times 3/4. Now 2 goes into 12 6 times, or 12 divided by 2 is 6, so that's going to be 6y. 12 times 2 is 24, 3 goes into 24 8 times, or you could say 3 goes into 12, 4 times 2 is 8. In either case, you're going to get 8x. So whatever your pleasure is on that. And negative, and then 3 times 12 is 36, 4 goes into 36 9 times. Or you could say 4 goes into 12 3 times. See, sometimes we can do what we call cross-canceling. See, 4 goes into 4 once, it goes in there 3 times, and 3 times 3 is 9. That's another way to do it. So that's going to be, either case, 9. Now, like I said, we could do this over here. 3 goes into 3 once. It goes in there 4 times 2 is 8. 4 goes into 12 3 times 3 is 9. Or 3 times 12 is 36 divided by 4 is 9. A couple ways to do it. And we got rid of our fractions. Now we want to get all of our numbers on the same side, so I'll subtract 8x to move it from the right to the left. And I have now negative 8x on the left plus 6, negative 8x plus 6y, excuse me. And that equals negative 9. So now I've got all my x's and y's on the left, my numbers on the right, except I've got a leading negative sign. Check, these are not all divisible by the same number, so I don't have to worry about that, but I do have a negative sign, so I want to change all those signs. So really we could just divide everything by negative 1 each term. and that's going to be the same thing, or just change all the signs. Either way, it accomplishes the same difference. So negative over negative is a positive, so I've got 8x, positive 8x. A positive over a negative is a negative, so I've got negative 6y. And a negative over a negative is a positive, so I've got positive 9. Now, if I would have changed all those signs, I would have just had a positive, negative, positive. So it's the same idea. And now this looks like this is in standard form. And I could always identify my A, B, and C once it's in standard form. So A is what? 8. B is negative 6. And C is 9. So there's your standard form. So that's probably the hardest type of problem you'll see when you've got 3 fractions and you've got all kinds of goodies to do. Okay? So I hope that helps.